Welcome to the math record. Today I'll be covering the second part of the integration of trigonometric functions. So the first form I'll cover is sine to the power of m, sine to the power of m, times cosine to the power of n. So this form, there's three conditions. Well, you only have to satisfy one of them. And either m is odd, or n is odd, or m and n are both even. So if one of these conditions are met and it's in this form, you can use the process that I'm going to show. So this process is basically just the same as the previous one, except there's just going to be an extra term. So let's say, for example, we have the integral of sine of 5x times cosine squared of x d of x. So the odd one is the sine, because it's the 5. So that means what we have to do is take away 1 from this sign. So sine of 4x times cosine squared of x times sine of x d of x. And then similar to what we did in previous video, we make this a squared times cosine squared of x times sine of x d of x. And then we use the Pythagorean identity, which is sine squared of x plus cosine squared of x equals 1. So we have our sine, so we substitute 1 minus cosine squared of x squared times cosine squared of x times sine of x d of x. And then we do a u substitution. So we say u is equal to cosine of x. So du equal the derivative of u is equal to the derivative of cosine of x, which is negative sine of x. So put the sine of x here, and then put the negative here, and then times d of x. So we know this one is right here, and we already have u for these. So substituting it in, we have 1 minus u squared, squared, times u squared, and then this is negative du. Okay, now let's delete these so we get room to do some more math. Okay, now let's expand this out. So 1 squared times this u squared times this 1 is 1 times u squared times negative 1, which is negative u squared. And then when we factor this out, this will give us a negative 2 u squared times the u squared, which is negative 2 u fourth times this negative is plus 2 u to the power fourth. And then negative u squared is u fourth times this u squared is u6 times this negative is negative u6 du. So all I did was just expand it out. I just didn't show the work. So the integral, and then when we take the integral of this, which is just using power rule, use the power 3. So the derivative of this is 3u squared, so we just need to make scale by 1/3. This is u to the power 5, so the derivative is 5u fourth, so we need to scale by 2/5 to get to 2u fourth. And then u to the power 7, the derivative of this is 7u6, then we need to scale by 1/7 to get to u to 6. And as usual, add a c. Now we substitute our u back in. So it's basically the same procedure as our previous method. Except for this procedure, okay, let me finish writing this first. So except for this procedure, for this method, we have an extra term if we're working with our sine. It's right here, we had our extra term. Or if we were working with cosine, then we were working with the extra term with sine. And that's basically it. Okay, now let's work with the second one, which is just a variation, but working with tangent and secant, or cotangent and secant. So let's move this a little bit over. So it's either tangent m to the power of x, tangent of x to the power of m, or times secant n times x, or it's cotangent m times x, power m times x, and secant n to the power of x dx. And the conditions to be met for this one is if m is odd, if n is even, or is n even, or if m is the one that's even, and n is the one that's odd. So, so it just needs to satisfy one of these conditions and be one of these forms. Okay, so let's try an example. Let's say we want to find the integral of tangent cube of x times secant cube of x dx. So it's in this form, and which condition does it meet? Well, the m is 3, so that's odd, so it satisfies this condition. So for this one, that means we have to take one away from here. So that's tangent squared of x times secant cube of x times tangent of x. So whichever condition it meets, whatever the term that is, always take away one from there. Okay, now the Pythagorean trig identity that we're going to use for this is just a variation of the Pythagorean, which is tangent squared of x equals secant squared of x minus 1. Or if we're working with cotangent, it'll be cotangent squared of x equals cosecant squared of x minus 1. Okay, so that's why they can work for either form, because it's generally the same process. So their tangent is secant squared of x minus 1 times secant cube of x times tangent of x dx. Okay, now what we have to do, as we did before, is that we use a u substitution. So u equals secant of x, whatever we substitute it in. So when we take the derivative of this, it'll be secant. The derivative of secant of x is secant of x times tangent of x dx. Okay, and from here, we could see that we could substitute u squared minus 1, and we could separate this out. It says secant squared of x times secant of x. So then this secant of x, this tangent of x, and this dx could satisfy this equation. So we have u squared left over because secant squared, and then that other secant, as I said before, goes with our du. Okay, now expanding this out, this gets us, distributing out u to the power 4 minus u squared du. Okay, now let's delete some of this as usual so that I could have room to do some math. And the integral of this is u to the power 5. The derivative of this is 5u fourth, so when you scale by 1/5, u to the power 3. The derivative of this is 3u squared, so when you scale by 1/3, remember to add the c. Now we need to substitute our u secant of x back in. So 1/5 secant 5th x minus 1/3 secant cube x plus the c. And that's the process is what we do for this. So it's just a variation of for our sine and cosine, but now working with tangent secant or cotangent secant. Okay, and our final form is going to deal with either the integral of sine of ax times sine of bx, or integrals of sine of ax times cosine of bx, or cosine of ax times cosine of bx. Okay, so there's the three different cases, either both sine, one cosine, or both cosine, and they're multiplied to each other. And for these, we're gonna have to use the trigonometric identity for the sum to products or products to sums, which is kind of long. 2 sine of the angle A times sine of B. So if they're both of the, I'll just put it to the side so we know which one to use for which. So for this, we use the trigonometric identity. 2 sine of A, sine of B, is equal to cosine of A minus B um, minus cosine of A plus B. For this one, it's 2 sine A cosine B is equal to sine of AB plus sine A minus B. And the final one, which is 2 cosine A cosine B is equal to cosine A minus B plus cosine A plus B. Okay, so you probably won't even want to remember these formulas, these three trigonometric formulas. You could usually just search them up. So it's going to be the sum to products or products to sum ones. Okay, now let's just try an example. So we have an integral of sine of 2x times cosine of 3x. So we have a sine, cosine, so we're using this one. So using this identity, we can combine it to make a um, sine, cosine, so 2x plus 3x is 5x. So sine of 5x plus a sine of a minus b, so 2x minus 3x, which means sine of negative x. And then we have our 2 in front. Remember, this is only singular, but this is double. So then we have to divide by 2. So just move a 1/2 outside. Okay, so the, to work from sine, we have a cosine. So cosine of 5x, the derivative of cosine 5x is negative sine 5x, chain inside, which is 5. So that means we need to scale this up by negative 1/5 to cancel both of these out. Okay, so negative 1/5 cosine of 5x. Okay, now sine of negative x. So that would be cosine of negative x. The derivative of cosine is negative sine, and then plug in negative x. And then the chain inside for negative x is negative. So cancel out this negative, so it would be sine of x, negative x. So that means our integral is cosine negative x. And then remember our 1/2 from outside. Multiply negative 1/10 cosine of 5x plus 1/2 cosine of negative x and add the trusty c. Well, that basically covers everything. Thanks for watching, and I'll see you at the next math record video.